Hello everybody. Today we're going to discuss about rules of inference, section 1.6. Introduction. Proofs in mathematics are valid arguments that establishes the truth of mathematical statements. An argument is a sequence of a statement that ends with the conclusion. A valid argument is an argument with the conclusion or final statement that follows from the truth of the preceding statement or premises of the argument. It is also an argument that is valid if and only if it is impossible for all the premises to be true and the conclusion to be false. Valid arguments in propositional logic. Consider the following argument. If you have a current password, then you can log onto the network. The argument can be broken down into the following. You have a current password. Let's call that premise P. Therefore, you can log onto the network. Let's call that Q. Then we can write the argument symbolically as follows. If P, then Q, or we can just write it as P on the bottom of the line, therefore Q. Valid arguments. We will know how to construct valid arguments in two stages. First for propositional logic and second for predicate logic. The rules of inference are the essential building blocks in the construction of valid arguments. Number one, for propositional logic, in order to build a valid argument or in order to build an argument, we use rules of inference. For predicate logic, in order to use, in order to construct an argument, we use rules of inference plus additional inference rules to handle variable and quantifiers. Rules of inference for propositional logic. We can always use a truth table to show that an argument is valid. However, sometimes some arguments involve a lot of proposition, which will require a long truth table. So therefore, instead of using a truth table to validate an argument, we may use rules of inference because they are not as lengthy as the truth table. Arguments in propositional logic. An argument in propositional logic is a sequence of propositions. All but the final proposition are called premises. The last statement is the conclusion. The argument is valid if the premises imply the conclusion. An argument form is an argument that is valid no matter what propositions are substituted into its propositional variable. If the premises are P1, P2, all the way to Pn, and the conclusion is Q, then P1 and P2 and P3 and P4 all the way to Pn implies Q. And this conditional statement is a tautology. Then we say this argument is a valid argument. Inference rules are all simple argument forms that will be used to construct more complex argument forms. Rules of inference for propositional logic. So the first one is modus ponens. If P, then Q. So this argument can be broken down P, therefore Q. So the tautology corresponding to modus ponens is displayed on the right of this slide. So example of Modus ponens are: let P be, it is raining. Let Q be, I will study math. If it is raining, then I will study math. It is raining. Therefore, I will study math. Modus tollens. So, for instance, you have an argument as such. If P then Q, not Q, therefore not P. Example: let P be, it is raining. Let Q be, I will study math. So using modus tollens, if it is raining, then I will study math. I will not study math, therefore it is not raining. Hypothetical syllogism. If P then Q, if Q then R, therefore P implies R. Let P be, it rains. Let Q be, I will study math. Let R be, I will get a B. If it rains, then I will study math. If I study math, I will get a B. Therefore, if it rains, I will get a B. Disjunctive syllogism. P or Q, not P, therefore Q. This is the form of disjunctive syllogism. Example: let P be, I will study math. Let Q be, I will study programming. I will study math or I will study programming. I will not study math, therefore I will study programming. Rule of addition. P, therefore P or Q. Example: let P be, I will study math. Let Q be, I will visit New York. I will study math, therefore I will study math or I will visit New York. Simplification. P and Q, therefore Q. Let P be, I will study math. Let Q be, I will study programming. I will study math and programming, therefore I will study math. Conjunction. P, Q, therefore P and Q. Example: let P be, I will study math. Let Q be, I will study programming. I will study math. I will study programming. Therefore, I will study math and I will study programming. Resolution. Not P or R, P or Q, therefore Q or R. Example: let P be, I will study math. Let R be, I will study programming. Let Q be, I will study history. I will not study math or I will study programming. I will study math or I will study history. Therefore, I will study history or I will study programming. This is the table of rules of inference. So, modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, and so forth. Using the rules of inference to build valid arguments. A valid argument is a sequence of a statement. Each statement is either a premise or follows from previous statements by rules of inference. The last statement is called conclusion. A valid argument takes the following form. So you start with premise 1, premise 2, all the way to the final conclusion. Valid arguments. Example. With this hypothesis, it is now sunny this afternoon and it is colder than yesterday. We will go swimming only if it is sunny. If we do not go swimming, then we will take a canoe trip. If we take a canoe trip, then we will be home by sunset. Using the inference rule, construct a valid argument for the conclusion, we will be home by sunset. Solution. Choose propositional variables. So let P be it is sunny this afternoon. Let R be we will go swimming. Let T be we will be home by sunset. Let Q be it is colder than yesterday. Let S be we will take a canoe trip. Translating into propositional logic. The hypothesis. So the first one, it is now sunny this afternoon and it is colder than yesterday. We can express that as not P and Q. So, and then the second premise would also be expressed at R imply P. The third premise would be expressed at not R implies S, and the fourth one would be expressed as S imply T, and the conclusion would be T. Valid argument. To construct valid argument, we have a step 1 through 8, and then in any of the steps we will mention the reason. For the first premise, not P and Q. So this is my premise number 1. If I use the rule of simplification, I will find the conclusion of the premise number 1 to be negative P. Again, if I use premise number 2, R imply P. If I use the rule of modus tollens, using number 3 and number 2 and number 3, I can come up with the conclusion not R. So using the premise not R implies S, if I consider 4 and 5 and I use the rule of modus ponens on 4 and 5, I can come up with the conclusion S. The fourth premise, S imply T. If I use the rule of modus ponens on 6 and 7, I can come up with the conclusion T. Handling quantify statements. Valid arguments for quantify statements are a sequence of statements. Each statement is either a premise or follows from previous statements by rules of inference, which includes rule of inference for propositional logic, rules of inference for quantify statements. The rules of inference for quantify statements are introduced in the next several slides. Universal instantiation. For all x, P of x. Therefore, P of C. Example. Our domain consists of all dogs, and Fido is a dog. All dogs are cuddly, therefore Fido is cuddly. Also, there is another rule called universal generalization. P of C for an arbitrary C. Therefore, for all x, P of x.
Existential instantiation. There is an x such that P of x. Therefore, P of C for some element C. Example: there is someone who got an A in the course. Let us call her A and say that A got an A.
Existential generalization. P of C for some element C. Therefore, there is an x such that P of x. Example: Michelle got an A in the class. Therefore, some got an A in the class.
The following are references used to construct this lecture.